In this problem, we would like to calculate the sum of all moments about point A. And we have the forces only 2,500 and 1,300 pounds. Now the force 2,500 is inclined, so we said always step number one is we need to resolve this force. And if you look at force 2,500 is like so. So we need to resolve this force into its x and y components. So this is the x component of the force, and this will be the y component of the force. Step number two is we'd like to see if we have the perpendicular distances between these forces and the point about which we are taking the sum of moments. Starting with the x component, this is the distance we need, which we have, it is 4 feet, and for the y component we need this distance, which we don't have. We do have the 8 and we have the 20, so we need to, based on these two measurements, to calculate the distance, which we are missing this part and this part of the distance. So as we used to say, we extend the lines to see, creating right angle triangles to see if we can find these distances. So if you look at this part, if you extend this line and this line, we'll get this 90-degree angle for this triangle. So we have this right angle triangle, and let's see if this right angle triangle will be beneficial to us in calculating the distances. See, this distance is this distance, so if we get this distance and we have the 20, you should be able to get this value. So we get all the distances calculated using this right angle triangle. Now we need to analyze this right angle triangle. So let's take this right angle triangle. Now this angle should be the remainder of 90, and which is 53.13 degrees. So this angle is equal to 53.13 degrees. Of course this is 90 degrees, so we'll know this value. So what we need to calculate here is, this is the unknown distance to us, and we know this distance because it is given. If you look at the sketch, this is 10 feet. So all we need to do is calculate this distance, and let's accept this distance to be dx1. So this will be dx1. To calculate dx1, we'll take the tangent of angle 53.13 degrees is equal to the opposite, which is 10 feet divided by dx1, and dx1 is equal to 10 feet divided by tangent 53.13 degrees, and dx1 is equal to 7.5 feet. So once we know the value of dx1 is equal to 7.5 feet, we have, and if we call this distance dx2, in that case dx2 is equal to 20 feet minus 8 feet minus 7.5 feet, and dx2 will be equal to 4.5 feet. So that's why we have the distances for all the forces that we would like to use in this sum of moments about point A. Now we need to calculate the values for components Fx and Fy, knowing the value of this angle here. So all we need to do is we have Fx is equal to 2500 cosine 36.87 degrees, which is equal to 2000 pounds. That's for Fx. And for Fy it is equal to 2500 sine 36.87 degrees, and this is equal to 1500 pounds. Now that we have calculated the value for the components. Now we need to define the rotation direction for these forces. So for this force it will rotate in this direction, which is positive, and for this component will rotate in this direction, which is negative, and this will rotate in this direction, which is positive. These are the three forces that will cause moment about point A. So now if we would go to calculate the sum of all moments, sum of all moments about A is equal to how much? I first start with the plus 1300 pounds multiplied by the distance. This is the distance, which is 4.5 feet. And then we have the other positive, which is F1x, and the value for F1 is plus. F1x is equal to 2000 pounds multiplied by the distance from here to here is equal to 4 feet. And then we have the Fy is minus negative minus Fy is equal to 1500 multiply the distance for Fy is equal to 8 plus 4.5, which is equal to 12.5 feet, is equal to how much? And the result is equal to minus 4000 pound foot. Minus means the rotation is clockwise. Now I will calculate the sum of moments about point B. So first we need to define the rotation direction for the forces, and for this force will be in this direction, which is clockwise, that is negative, and for this force Fy will be counterclockwise, which is positive, and for the Fx will be also counterclockwise, which is positive. So now we just do the sum. We already have the distances, so the sum of moments about point B is equal to how much? Well, we start with the first one, which is negative, so it is minus 1300 pounds multiplied by the distance between this force and point B is 8 plus 7.5, which is 15.5 feet. And then we will do the force Fx, which is again it is positive, and Fx is equal to 2000 pounds, and this in between Fx and this is 10 feet. And then Fy again is positive, so plus Fy is equal to 1500 pounds, and the distance for Fy is 7.5 feet, is equal to how much? And the end result for this is equal to 8,000 pounds. Foot, and because it is positive, so it will be counterclockwise.